Section called Systems of Equations. Today we're going to be going over how to use graphing and tables to solve systems of equations. First of all, let's start with a solution is an ordered pair. It's an ordered pair that satisfies each equation in the system. It's the point where two lines cross. So it's an ordered pair that satisfies each equation in the system, the point where two lines cross. There are three types of solutions. The first is one solution, xy. You have one line here, and you have one line here. And the solution is where they meet. So that's the solution right here. These are called intersecting lines. Let's see if I can write it out. Intersecting lines. So that's one solution. We have no solution. This is the empty set, or that. These would be parallel lines. So the lines never meet. And you can list it as something like that if you want to. And then our last one would be infinite solutions. So that would mean you have all real numbers. This is when you have two lines that are the same line. So this is the same line. Or the same lines, they're the same. So you have one solution, no solution, or infinite solutions. The majority are one solution. So when we're doing our graphing, we always have to have it in y equals format, especially to plug it into the calculator. But if we're doing our graphing, we want to put it in y equals. So we can see this first one already is. And actually it's y equals mx plus b, so it's our slope-intercept form. The second one is not right now. So what should we do? Well, we need to work it out. Subtract 6x from both sides. So I have 3y equals negative 6x minus 9. So now I need to divide everything by 3. So I have y equals negative 6x divided by 3 is negative 2x. Negative 9 divided by 3 is minus 3. So we see these two are the same line. So that means our answer is all reals, meaning they are the same line. So hopefully you can see that. So they both become y equals negative 2x minus 3. They are the same line. All right, the next one. So our first y equals 2/3 x plus 5 is fine. Now we need to set up our second equation. So we need to subtract our 2x. So we have negative 3y equals negative 2x plus 12. Then I need to divide by negative 3. So then I get y is equal to positive 2/3 x 12 divided by negative 3 is minus 4. So as we look at both of these, they each have the same slope, but they have a different y-intercept. So that means they have no solution. These are parallel lines. They never touch. They never touch each other. And then this last one, they're both in y equals. We have y equals 4x plus 3 and y equals 3. So if we were going to graph this, y equals 3 is going to look like this, and y equals 4x plus 3 goes through here and has a slope of 4. They're going to hit right here. Solution would be 0, 3, meaning the lines cross at 0, 3. Okay, so take a look. We have one solution, no solutions, infinite solutions. All right, so let's flip it over, flip the page over. And let me get it set up. So now we have some tables. So if you look at our tables, you can see the x values and then see what happens with our y values when x is 12, negative 12. They're both the same. At negative 9, they're both the same. At negative 3, at negative 6, they're all the same. At negative 3, they're all the same. And at 0, they're all the same. So every point matches up. So that means we have all reals. This is the same line. If we look at the number 5, we can see negative 2, they don't match up. But then if we look, we can see at 0, negative 2, both graphs or both tables meet. So our solution would be 0, negative 2. Now as we're looking at number 6, we look x values, x 1 to 6, 2 to 5, 3 to 4, 4 to 3, 5 to 2. And then we see x negative 2, x is 2, y is negative 3. So in this case, no y values are matching up between the two lines. So that means, we could do all of the graph, but we can see the difference as x is getting larger, our y value is getting smaller at the same rate. So that means we have no solution, no y values match up. On your calculator, after you've graphed, you can hit Control T to form a table. On the calculator. Okay, and that's all we have for graphing.